Hello, wonderful people. All right. Come on. Unlock iPad. There we go. All right. So, once again, this afternoon, I'm going to go over a couple more proofs to help any students out. If you need to, send me a message on Remind, and I'll be more than happy to do a proof live for you. So, here is our first proof we have today. It is two triangles, and we need to prove that triangle AEC is congruent to triangle DFB. So the first thing I'm going to do, like always, is I'm going to just draw the picture. And if you hear some music in the background, that is just my lovely wife practicing her kalimba. So here's my picture, A, B, C, D, and D, and then we have E and F. So that's number one. We are given that AE is parallel to FD. That's going to be very beneficial because that means if we look at the nice, wonderful transversal that's going through those parallel lines, it'll give us 2 or 4 angles that are congruent. So the next thing is AE is congruent to FD. So I'm going to mark that. That's congruent. And finally, AC is congruent to BD. Now that's a little bit harder to mark with the way it is. So what I'm going to do instead is I'm going to take these two triangles apart for right now. I'm actually going to turn AE over like this and have C come down like this. And then I'm going to do the same exact thing with B, F, and D. But whenever I redraw my picture, what I'm going to do is make sure I label. So in green, I have AE being the same as FD. And now I can color in A to C. Right here are AC and BD are the same. So going back to our 5 different types of congruencies, we have side, 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 angle, side, angle, side, angle, 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 side, and HL. Well, to begin with, I'm going to cross out HL, hypotenuse leg, because that requires us to have a nice, wonderful right angle. And since this problem does not say anything about perpendicular lines or right angles, I know that we're never going to come across it. So that takes care of that. Now, we are good with AC and BD. So that's one thing. That's a side. So that means we have this one, this one, this one, or this one. And we have AE and FD are the same. So that's another side. So this one, and now this one is wrong, and this one is wrong. Which means I'm looking for either another angle or another side. Well, if I go back to the top one, AE is parallel to FD. That's the one that I said we're going to be looking for a transversal. So this one's a little bit hard to see for some of us. We need to turn our head a little to the left. And when you turn it to your left, you will notice that if we kind of rewrite, well, let me draw this picture a little bit different. I want that. And then we need this, this, and this. So here's our A, our B, our C, our D, and F, N, E. Now you will notice that we can easily see that this angle and this angle are what's called alternate interior angles. So for my next step, I'm going to type in 2 angles are congruent because they are interior. And it's the second one, parallel lines cut by a transversal form congruent alternate interior angles. So now I just need to label my two angles. Well, this is by A right here. That's what I want. And I want this one. So for that top one, we go from the E to the A to the C. So EAC is our first one. Our second one is going to be, now notice we started with the green side. So we're going to start with the green side. F to D to B. F, D, B. Those two angles would be congruent. So I'm going to hit try. And there we go. We have our congruencies. So now, when we take a look at this, let me get rid of that stuff. You can see that we're going to have a side. Oopsie. We have a side. We have an angle. And we have another side. So that is side, angle, side. So I can say the two triangles are congruent by side, angle, side. And what I'm going to do to make sure I line up the letters correctly, I'm going to go all the way up to the top. And I'm going to copy A, E, C. And then the other one, D, F, B. I'm going to hit try. And there we go. It is solved. So it just takes you a moment. You have to draw the pictures. You have to separate the pictures. Sometimes you need to turn your head so then you can see the pictures in a different light. Remember, if you have a question you want me to go over on your homework, just send me a remind message. I have my phone right by me, so then we can do that one for you. So my next problem I'm going to try. Ooh, a good old kite. So number 2. We're given some information. We have to prove two triangles are congruent. Like always, the first thing I'm going to do every single time, I'm going to draw a picture of what I see. And then we have a line going down the middle. And we have A, B, C, and D. And we have a hash on those two. Once I draw the original picture, I'm going to draw the triangles that I want to prove are congruent. So in this case, we need triangle ABC. So that would be, well, not ABC, ABC. Oh no! Hold on. That's the wrong letters there. Makes a big difference if you don't put the letters down correctly. My iPad screen disappeared. That's what I get for having this off-brand USB-C cable. So give me 1 second. I think... There it is. All right. So A is up here. B is here. C is here. And then we have the other triangle that's right next to it. A, D, and C. So now, I know that I have B and A. And remember, we're looking for side, 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 angle, side, angle, side, angle, 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 side, and HL. And HL is always for right triangles only. Well, I look in this and believe it or not, they actually gave me things that could tell me it's a right triangle. So that might actually be this one. But first, I'm going to go over. The thing that I see is they both share this very long AC line with each other. So I am going to automatically say AC is congruent to AC because of reflexive. Reflexive is pretty much like reflection, where you're looking at your same exact thing. So there we go. So now, what I know right now is I have two sides. So I'm going to go down. Side, side, side is possible. Side, angle, side is possible. Angle, side, angle, not possible right now, because I already have two sides. And once again, same thing with angle, angle, side. Not possible because I have two sides. So that means I have side, 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 side angle side, or HL. From here, I go all the way back to step 1. AD is congruent to AB. I don't need to worry about that because that's just a fact, and we already have that information. The next information is our side BD, AB is perpendicular to BC. Well, I know the word perpendicular means right angle. So what I want to do is say that that blue angle is a right angle. So I'm going to classify A to B to C. A, B, C is a right angle because perpendicular lines form right angles. Cool. Once I go down below it, we have the same idea on the other side with AD and DC. So that means there's another perpendicular line. Oh, we have another right angle. And that is going to be ADC. It's because of perpendicular lines. So now that I have two right angles, I'm going to pick HL, which stands for hypotenuse leg. What that means is in a right triangle, if the hypotenuse, which is the longest side, and one of the legs, one of the shorter sides, are congruent, then the entire triangle is congruent. This is where delta math gets really silly though. Because in order to use the HL theorem, you have to say that both triangles are right triangles. So what I need to do for step 5 and 6 is classify the triangle ABC is a right triangle because the triangle consists of a right angle. And I also need to classify triangle ADC as a right because it has a right angle. You have to say that those two triangles are right triangles first in order to use the statement that they are HL, hypotenuse leg. Because hypotenuse leg only works for right triangles, and in a proof you have to say something is a right triangle. You can't just assume it is. So I'm going to type in ABC is congruent to ADC, hit try, and there we go. We have now proven that those two triangles are 100% identical. They are congruent by saying that they were two right triangles that share the same hypotenuse, and one of their legs was congruent. All right. So I just got a message from a student asking for me to do one. So let's take a look at this student-generated question. Number 3. We are given the following shape. Now, because the question that the student is asking is not like what is up on the screen right now, this is going to be a little different. So let me switch over to just the iPad capture. This is going to be different because our program, Delta Math, kind of does things differently than what I would do sometimes. So they have all the steps already, so I just need to fill in what they know. So let's start with our statements and our reason. Statement number 1 is, zoom in, AC is congruent to CB, given. So AC and CB is congruent. They also gave us AB is perpendicular. Perpendicular to CE. Given. Whoa, what happened? Oh my gosh, this darn cable. I'm going to have to spend money and actually get a real cable here because I just keep losing connection. So So sorry about that. Give it a second. And there we go. All right, so we're back. And we need to prove. So what we want to prove is angle ACD is congruent to angle BCD. So if I was doing this program without delta math, my assumption would be, since I want to find this angle and this angle, that means I only really care about these two. I want to prove that those two triangles are congruent. So, delta math says the first thing that they proved was angle ADC is a right angle because of depth of perpendicular. Perfect. I love it. Okay. That's a true statement. Because what delta math is going to be doing is proving that this triangle, ACD, is a right triangle. And this triangle, CDB, are both right triangles. They both have the same hypotenuse. And they share the same leg. Therefore, there are congruent triangles. So we're going to first prove HL. Then, using that two triangles, we're going to say CPCTC. Congruent parts of congruent triangles are congruent. So we now said that, which also means we need to say same thing for this. So angle CDB is right because, once again, it's a depth of perpendicular bisector. Or not perpendicular bisector, just perpendicular. Step 4 and 5. I'm going to combine them. Triangle ADC and triangle BDC are right triangles. That's true because they both have a right angle and it's a triangle. So if a triangle has a right angle in it, it has to be a right triangle. So that was 4 and 5. Step 6. Come on, pencil. Switch over. Step 6 says that CD is congruent to CD because it's reflexive. So it's going to be congruent to itself. From there, we can say the two triangles are congruent. So triangle, what delta math? ACD congruent to triangle BCD. And like I said, this is going to be HL because the red line is the hypotenuse, the pink one is a leg, and the blue right angle is the right angle. So it works. And then finally we get to the proof. 8. ACD is congruent to angle BCD because of CPCTC. Congruent parts of congruent triangles are congruent. And that's it. And that is how you would solve that one problem. So like I said, if you have any questions, feel free to send me on Remind, and I will do the same exact thing that I just did there. Oh, we have another problem coming. Oh, of course, my iPad goes crazy. All right. Interesting. That is definitely one way to say it to me. So the only problem I have with that last picture, I need the bottom of the proof. What do I prove? So, question number 4. We have a beautiful picture, and if I don't know what I'm proving, there are so many different things. in this one. This is, yeah. A, B, C, D, and E. State. Reason. Did I get an answer yet for what I need to prove? No, not yet. Tell me what I need to prove. So, we were given one AC and BD bisect. Given. And that's kind of where I got to stop at the moment. Without knowing what two triangles I want to prove are congruent, because in all honesty, oh, there it is, maybe. All the triangles are congruent. Okay, they said prove triangle BEC and triangle DEA. There we go. Okay, that's going to be much easier now. Now I know what I'm looking for. So like always, the first thing I'm going to do, let me redraw the triangles. So it's this top triangle, BEC and DEA. That's underneath. E is up there. All right. So, what'd you say first? Reflective property. CA is congruent to CA. That will not help you at all. The only thing that will help you from the given is going to be, let's see here, AC bisects. So that means this. AE is congruent to CE. And the reason is because definition of bisect. So now we have a side in common. And I'm going to shoot for side angle side because of the word bisect and because they both have that E that's almost the same. So our third step is going to be BE is congruent to DE. Once again, definition of bisect. And finally, these two angles are congruent. So step 4, angle BEC is congruent. Notice I start with the green side, so I'm going to continue with the green side, DEA, by vertical angles. They are directly across from each other, so they are vertical. And then finally, step 5, BEC is congruent to DEA by side angle side. And that's how you would prove that those two triangles are congruent. So if you have any other questions, like I said, just message me on Remind. I'll do a couple more. Well, you're welcome. All right, so let's go back to the iPad and Delta Math screen. So here's my next problem. Number 5. All right, this is a very common one that I see a lot on Delta Math. So, like always, the first step I'm always going to do, draw a picture. It does not have to look 100% identical. Oh, there's no B in this one. A, E, D, F, C. We are given ED and FD are the same. And we are also given this one and this one are the same. So like always, side, 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 angle, side, angle, side, angle, 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 side, and HL. Well, looking right away, they did not give us anything for perpendicular. Therefore, I'm not going to use HL at all. So HL is gone. I have two sides. That means that angle, side, angle, and angle, angle, side are incorrect as well. So now I need to either find another side or another angle. Since I've already used both of the givens, that means the only possible answer has to be something that is obvious. Well, what is obvious is going to be these two angles right here. They are across from each other, so they are vertical. So I'm going to say two angles are congruent because of vertical. All vertical angles. Now, I'm going to start with my red side. So E to D to A, the green, E, D, A. And the other red is F to D to C, F, D, C. Boom. There we go. Now I have two triangles that are congruent by side, angle, side. And I could just look up at the proof, ADE and CDF. All done. Sorry, that was me slapping my tattoo since it's itchy. All right. Very good, very good, very good. All right, let's do one more like this. And then if there are any questions, I'll answer them. If not, I will do a couple flowcharts maybe. Oopsie, I clicked the wrong button. See, my brain was like, oh, we should do flowcharts already. All right. Cool. Number 6. First step, like always, is copy the picture. That is the one biggest thing I could tell any math student. You need to copy the picture. A, B, C, D. And then you have BC and AD. And then you have AB and CD the same. So this does not give you any too much extra information. So the only thing I can say is, hey, look, this AC down in the center, AC is the same thing as AC. So I'm going to say a line AC is congruent to AC. A line is congruent to itself because of reflexive. I have enough information now. I have a red side, I have a green side, and I have a blue side. So therefore, these two triangles are congruent by side, side, side. ABC and CBA. Oh, a very nice, fast problem. All right. Submit answer. Yes. And we got it right. Yay. That's it. All right. So. Oh, no, not those ones. Level 1s. All right. So here we go with some flowcharts. So like always, the first thing I'm going to do, draw a picture. If you learn anything from all this math, I hope it's learning that you have to draw pictures. And they gave us this and this. So, in these flowcharts, the very first top box is going to be your written given, which in this case is the AC bisects angle BCD. So, line. AC. Whoa, that's way too many things. AC bisects BCD, and that is going to be our written given. Now, our next thing is talking about what it actually means. So, bisect means to cut something in half. Well, this is cutting an angle in half. So that means I'm going to have an angle is congruent to an angle. And the reason is because it's the literal definition of bisector. Angle bisector divides an angle into two congruent angles. So now we just got to say the two angles. Well, I'm going to go here to here. So that's angle BAC. BAC. And then we're going to do the same thing. We're going to start with the red side. So DAC. Angle DAC. There we go. Now I can look at my reasons on the bottom. They want us to have angle, angle, side. Well, here's an angle.
Oh shit, what?
AC. Oopsie, this is in the wrong spot.
Okay.
So I messed up. These two angles should be over here. And the reason why is because the angle that we were actually bisecting was this purple one. So I need to flip this and put this BAC over here and the DAC, and that's just a given because it was in the picture. So now I need to redo this. So we're looking at the top angle, the pink one. So we're going to go from B to C, and then we're going to go down to A. And then the other one will be DCA. There we go. So now we have an angle. We have an angle. And now we need our side. And the side they gave us is BA, BA, and DA. And that's a given. Now let's try that answer. Oh, there it goes. So that's a nice flow chart. All right, I'm going to do one more and then I'm going to take a quick break. I will leave this open, and if you need to send me a message, I'll put a timer on for about 10 minutes. If not, I'll be ending the video here today. So, here is my last problem I have planned on going over, number 8. And we have a beautiful picture, like always. First step. And then we have this one and this one. And that's it. Cool. So, here we have two written givens. And
Where is that extra sound coming from?
this cable broke again. Pupper snoring?
No, in the song, I'm trying to think and I can't think and I can't hear.
Come on, iPad. There you go. We have D is the midpoint of AC. So I'm going to say down here, midpoint. D is the midpoint of AC. That's a given. And the other one, BD, is an angle bisector. BD bisects angle ABC. Given. So now we're going to start with the midpoint. It said D is the middle. So that means CD is congruent to AD. That's what midpoint means. It's equal to each other. So I'm going to go in here. I'm going to type in CD, AD, and I'm going to type in midpoint, MIDP. Oh, there it is. A midpoint divides a segment into two congruent pieces. Now, I'm going to try not to mess up this time and read correctly. So, we are dividing angle ABC, this angle, into these two pieces. So that's going to be angle ABD and angle CBD. Boom. Make sure I write it down this time. This way it's easier for me. ABD and CBD. And that is just the definition of bisect again. BIS. An angle bisector divides an angle. And my final reason is going to be the given, which is angle C and angle A. Now, for these, I can say angle C and angle A because there is no other angles by there. There's only one angle. And that's going to be a given. Angle, angle, side. I have two angles. I have a side. Submit. And it worked. So that's it. So, I'm going to take a quick break for a moment. If you have any questions, please feel free to send me a remind message. If I don't get any responses by 7:45, I'm going to end the nice, wonderful video here, and you can feel free to rewatch this. All right, so I'll be right back, but feel free to send me a remind message if you need something. Alrighty, so since I did not get any more messages, I'm going to end it here. So thank you for tuning in. I appreciate it, and have a good day. Bye.